Hi everyone, I hope you are doing well. So in this video, we are going to discuss Leetcode problem of the day, and today's problem is special positions in a binary matrix, and it is an easy level problem. So the problem says that we have been given a n into m binary matrix and we just have to find the special positions in the binary matrix. So what are those special positions? These are positions where matrix of ij is equals to 1 and all the other elements in the ith row and the jth column are 0. Right. So basically, for example, this particular one is a special position because in this particular row and column, all the other elements are 0. But these two ones cannot be taken because they are in the same column. Right. So this is what the question is all about. Now, you can obviously go through all the elements, and as soon as you encounter even a single one, from then what you can do is you can start checking the current row and the current column. But let's say, let me just draw it as well. So if I have, let's say, a grid like this, and let's say you encountered a 1 here. So from here you will start checking the current row and you will start checking the current column. So what will be the complexity of this? So the complexity will be you're going through all the cells, so that is n into m, right? And whenever you encounter a 1, you're going through the current row and current column, so that will be multiplied by n plus n. Right, so this will be the worst case complexity of this particular solution. I would say it is roughly n cube. Right. Now, to avoid this particular complexity, what you can do is you can do this second part in constant time with some pre-computation. Although it is an easy level problem, the test case might still get passed, but I'm just discussing it so that we have a better solution. So what you can do is to optimize this particular part, we can compute the number of ones in each rows and columns, right? So the next time whenever we encounter a 1, we can directly check how many ones are there in this particular row. If there is only a single one, then only I am going to take it in the current row and the current column, otherwise I am not going to take it, right? So I already have the row and column count, the number of ones in each rows and each columns. If I encounter a 1, I have to check whether the number of ones in the current row and the current column is equals to 1 only, then only I am going to add this to my answer. So here you can see I have initialized my n and m variables with the dimensions of the matrix, and I have initialized two vectors row and column, which are basically going to store the number of ones in the ith row and the number of ones in the jth column. Right. Now I am just going to traverse through the whole matrix. If matrix of ij is equals to 1, I am going to increment my current row and I am going to increment my current column. At the end I can just initialize my answer and then again go through the whole matrix, and I am going to add this particular boolean expression to my answer. So whenever this boolean expression returns true, 1 will be get added, otherwise 0 will get added. So this expression contains of three terms. The first one is the matrix of ij itself, that means the current element is 1, and row of I is equals to 1, that means the current row has only one obviously, and the column of j is also equals to 1, that means the current column should also have one only, right? So at the end I can just return my answer variable, and this would be the final solution. So let me just quickly submit this. And how did our complexity got improved? This part which was taking O of this part which was taking n plus m time now has been reduced to 1. So the overall time complexity is now only O of n into m, right? So you see it is also getting accepted and the solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is for today. Till the next video drops, keep coding, stay safe, bye bye.